So the data required to give plasticity to our model is, let me show you. Okay, is this one. This is the mild steel stress versus strain and load versus displacement curve. This one is obtained from tensile test laboratory report of University of Botswana Material Science for Engineering. So this is the link from which you can obtain this data. Okay, let's go back to our model. Here in this model tree you can see there is a calibration option. So if you click that, so create a name, calibration 1, we'll let it be. Then in the calibration 1 there is a data set, and double click on that. Then the strain versus stress data set we have to fill from the Excel sheet we have just seen. So this is the data. Okay, let's copy that. Okay, after this you can see the data set has been imported. Here in this data set there is an option called process, and in data set processing we will choose the operation convert, then continue. So change the data, that is the engineering stress strain curve, so we need the true stress strain curve, so we'll change that and you can name it as true stress strain. Hit OK. The true stress strain curve data is plotted. Then go to behavior. Then you can see that there is elastic isotropic and elastic plastic isotropic. So we'll select elastic plastic isotropic, then continue. In the data set we want the true stress strain curve, and here in this we need to select an ultimate point. Let's see, I think this will be pretty accurate. Then for the yield point we have to select so that it coincides with the linear part. Okay, as you can see it should perfectly coincide with the linear part. Okay, so then Poisson ratio you can select. Before that you have to introduce plastic points to introduce plasticity in a model. So if we move that arrow, so it will increase the number of plastic points. So it has to be a optimal value, not too much, just a minimum to introduce plasticity. So then in this window we have to create a material, that is, let's say steel new. Then go to mechanical. We don't need to introduce elasticity or plasticity, just create a material, then hit OK. Then to get all the data here into that new path, new material, we just selected a new material, then hit apply. As you can see, the calibration parameter have successfully mapped to steel new. Dismiss that, cancel it, save changes yes, dismiss. Then go to part, go to property. In the steel new, go to edit. As you can see, the plastic part is given. So we need only the plastic point up to the deformation, not after the deformation. So after the deformation we need to delete all these points after deformation. let's delete all this point. Okay, then hit OK. And we will do the plastic part. The yield stress and corresponding plastic strain is obtained. In the elastic part, we have to select 10,000, 210 GPa and 0.3 for Poisson's ratio. Okay, then dismiss that. Create a section, new section for still new property. Still new section. That will be solid and type will be homogeneous. Continue. Material will be still new. Okay, dismiss that. Then assign the section. Here you can edit here. In this section type, still section, you will select the still new section. Hit OK, dismiss. Then go to job, then submit. Let's monitor the process. It will take some time. As you can see, this job is completed. Then let's go to result.